we want to find radical 2 plus radical 2i. We want to find this to the fourth power. All right, there's a couple ways to do this. You do not want to do it this way. So radical 2 minus radical 2i, right? Well, we're just going to multiply it by itself 4 times. Okay? Which, I guess we can do, right? We'll just FOIL this out, simplify, then multiply it by this again, and multiply this again, right? Essentially 4 times. Well, okay, that's fine, right? Maybe we can do this because it's to the fourth power, but what if it's a higher power, like to the fifth, sixth, seventh, right? So there is another way to do this, right? Remember, this is a complex number, right? A plus bi, right? Which we can actually write it in polar form of a complex number, right? R times the cosine of theta plus I sine of theta. And this should give us a big hint. Okay, if I take this complex number and write it in its polar form, then I can just use de Moivre's theorem to find this to the fourth power, right? That's going to be r to the fourth power, and then cosine of 4 times the angle, right? Plus I sine 4 times the angle, right? In this case, okay, because it's going to be to the fourth power. Okay. So what do we want to do then? The first thing we want to do is we want to write this in its polar form. Okay. Now you don't need to do this here, but let's plot this out. Okay. We got rad 2 over 2, rad 2 over 2, right? Essentially, this point, okay, is hanging out here in the first quadrant. Okay. So we got rad 2 over 2 this way, rad 2 over 2 this way. So what we want to do is we want to find this r and this angle right there. Okay. We know that r squared is equal to a squared plus b squared. We know that the tangent of theta is equal to b over a. What do we have in this case? Okay. So r squared is going to equal radical 2 squared plus radical 2 squared. Okay. R squared is going to equal, okay, that's just 2. 2 plus 2 is 4. R is going to equal the square root of that, which is just a positive 2. Not plus and minus, right? Technically, it is plus and minus, but because we are dealing with r, which is a positive number, right, r will always be positive. Okay. Similarly, tangent of theta is going to equal radical 2 over radical 2, which is just equal to 1. Okay, in quadrant 1, do I know where tangent is equal to 1? And we do, right? In this case, theta is equal to pi over 4. So we can rewrite this in its polar form as, right? Remember, this was radical 2 plus radical 2i, right? So this in polar form would be what? 2 times the cosine of pi over 4 plus I sine of pi over 4. But what do we want to find? We want to find this to the fourth power. So that's going to be 2 to the fourth power times the cosine of 4 times pi over 4 plus I sine now of 4 times pi over 4. Notice what we get in this case, right? Okay, 2 to the fourth power. Okay, 2 to the fourth power, that's just 16. And then we get cosine of pi plus I sine of pi. Okay, this is what we get. This is z to the fourth power. Okay, now this is the polar form, right? In complex form, we would just plug in what cosine of pi and the sine of pi is equal to, right? Well, cosine of pi, that's just -1. And the sine of pi is just 0. This is actually just equal to -16. Right? Let's think about that, right? If you actually sat down and you FOILed this out, and then you multiplied it with this, and you multiplied it with that, right? This is just going to equal -16. Okay, of course, it should equal the same thing here. Okay, so whenever we want to find powers of complex numbers, it's easier, okay, to convert it to its polar form, okay, and then use de Moivre's theorem to find that power.